Hello viewers, I am Kausalya. Today we are going to solve example problems in trigonometric ratios. The problem is given tan A is equal to 4 by 3. Find the other trigonometric ratios of the angle A. So here the value of tan A is given. We are asked to find the other trigonometric ratios. So what do you mean by trigonometric ratios? They are nothing but since the value here is a, right? So tan a is given, so we need to find sin a, cos a, cosecant a, secant a and cot a, right? So the first thing is, you see tan a is nothing but it is opposite side by adjacent side, right? So here the value is directly given in the problem, so it is 4 by 3. So we have to draw a right angle triangle, right? A, B and C. Again the naming of the triangle is up to you. Okay, even you can name it as A, B, C, whatever may be. So here the angle is given at A, right? So here I had mentioned the name as A, B, C. So here this is our angle, right? So tan A is opposite by adjacent. So to this angle, what is the opposite side? This side BC is your opposite side. So the value of the opposite side is 4. So just mark it as 4. Right. And again adjacent side is 3. So to this angle A, what is the adjacent side? This is your adjacent side. Right. So here the value is 3. So since we need to find the different values, that is sin A, cos A, right, cosecant, secant. So all these ratios need the value of hypotenuse, right, because the formula for sin theta is opposite side by hypotenuse. So in this triangle, this side AC is the hypotenuse, right, this is the lengthiest side. So how to find the value of this? By using Pythagoras theorem. So when you apply Pythagoras theorem, you see AC square is equal to AB square plus BC square, right? So we know the value of AB and BC. So just substitute it. It is 3 square plus 4 square. So 3 square is 9 and 4 square is 16. When you add, the answer is 25. So the value of AC square is 25. So the value of AC is, you have to take square root. So square root of 25 is nothing but 5, right? Now we know all the values of the sides of the triangle. So now we can easily find the trigonometric ratios. So here sin A. So sin A is nothing but opposite side by hypotenuse. So this is our angle A. So this is your opposite side and this is your hypotenuse. So the answer is 4 by 5. And the next one is cos A. It is adjacent side by hypotenuse. So to this angle A, this is your adjacent side. So the value is 3 and the hypotenuse is again 5. So the answer is 3 by 5, right? And the value of tan A is already given. So the next thing is cosecant A. So cosecant A is nothing but it is the reciprocal of sin A, right? So it is 1 by sin A. What is sin A? Sin A is 4 by 5. Right. When you move this denominator term to the numerator, it becomes 5 by 4. So cosecant A is 5 by 4, just reciprocal of sin A. You see sin A is 4 by 5. Therefore cosecant A is 5 by 4. And the next one is secant A. So secant A is nothing but it is the reciprocal of cos A. So here cos A is 3 by 5. Right. Once you take reciprocal, it becomes 5 by 3. And finally cot A. Cot A is nothing but it is the reciprocal of tan A. So the value of tan A is directly given in the problem. Just you have to reciprocate. So here the answer is 3 by 4. Right. So now we will move with the next problem. So our next problem is, consider triangle ACB right angled at C. What do you mean by right angled at C? That is, the angle of C is 90 degrees. Right, you see. Here I have drawn as A, B and C and the C is right angled. Right. So in which AB is equal to 29 and BC is equal to 21 units. And angle ABC is equal to theta. So we have to find the values of cos square theta plus sin square theta and cos square theta minus sin square theta. So here the first step is we should draw the diagram correctly. Right, once the diagram is drawn, then it is very easy. So first draw a triangle in such a way that angle C has 90 degree. Right. So here you see angle C has 90 degree. A, B and C. And here what is the value of AB? It is 29 and the BC is 21. So just write down the values. AB is 29 and BC is 21. Right. Now we are going to apply Pythagoras theorem and we are going to find the value of AC. Right. Because here you see we need the value of cos theta and sin theta. Right. So before that you see angle ABC is equal to theta. That is angle B holds the value of angle theta. Right. So we have to mark theta at the side of BC with a B side angle. Right. So when you apply Pythagoras theorem, you see AB square is equal to AC square plus BC square. But what we need actually? We need AC square. So keep this AC square this side as such, and once you move this plus BC square to the left hand side, that becomes minus BC square. Right. So the value of AC, it is nothing but it is square root of AB square minus BC square. So value of AB is 29 and the value of BC is 21. Right. So here just for our convenience, this is like the formula A square minus B square. Right. The value of A is 29 and the value of B is 21. So what is the formula? It is nothing but A plus B into A minus B. Right. So rather than taking the square root of this big number, we can do like this way. It will be easier. Right. So A plus B. So the value of A is 29 and the value of B is 21. So 29 plus 21 and A minus B is 29 minus 21. Right. So here the answer is 29 plus 21 gives you 50 and 29 minus 21 gives you 8. So once you multiply 50 into 8 gives 400 and once you take square root that becomes 20. Right. Now the value of AC we have calculated is 20. So now we can easily find out the value of sin theta and cos theta. Right. So what is the value of sin theta? You see this is the angle theta. So the formula for sin theta is opposite by hypotenuse. So what is the opposite side? So AC is the opposite side and AB is the hypotenuse. So it is AC by AB. So value of AC is 20, AB is 29. Right. Similarly cos theta. So what is the value of cos theta? So cos theta is nothing but adjacent by hypotenuse. So here the adjacent is BC divided by AB. So cos theta is equal to BC by AB, which is nothing but 21 by 29. Right. So now we are going to solve the given things. So the first one is cos square theta plus sin square theta. So you see cos square theta can be written as cos theta the whole square. Right. Similarly for sin theta. So cos theta the whole square. What is the value of cos theta? It is 21 by 29. Therefore 21 by 29 the whole square plus the value of sin theta is 20 by 29. So it is 20 by 29 whole square. Right. So since the denominator term is same, right? So we are adding the numerators. So 21 square plus 20 square. So 21 square is 441 and 20 square is 400 and 29 square is it is 841. Right. So here once you add we are getting you see 841 by 841 which is equal to 1. Right. Now the second part of the problem is cos square theta minus sin square theta. So the same thing, okay, cos square theta can be written as cos theta whole square and sin square theta as sin theta whole square. So just substitute the values, right? Again you see the denominator term is same, so we can subtract. So 21 square minus 20 square. So here again I have splitted these terms as a square minus b square, right? So it is a plus b into a minus b. So a plus b is 21 plus 20, which is 41, and 21 minus 20 is 1. So divided by 29 square is 841. So here it is 41 by 841. Right. Now we will move with the next problem. So you see that is 29 square. You can directly solve it as 29 into 29. Right. Or else you can split this one as 20 plus 9 whole square. That is, this is in the form of a plus b whole square. Therefore, a square plus b square plus 2ab. Right. So this is one form of finding the squaring of a number. Right. It's up to you. You can directly do by this method or you can use this method. Okay, this will be quite simpler. Okay, you won't make any mistakes. It will be because the multiplication will be done by using some simple numbers, so it will be easy, right? So it's up to you. You can either use this method or you can go by this, right? Now we are moving with our next problem. So here the problem is, in a right angle triangle ABC, right angled at B, right? If tan A is equal to 1, then verify that 2 sin A cos A is equal to 1. So here the thing is, a right angle triangle is given, right? And it is right angled at B. And the value of tan A is given. You have to find the value of, that is, you have to check whether the value of 2 sin A cos A is equal to 1. That's it. So again draw a right angle triangle and it is right angled at B, right? That's it. Now the value of tan A is equal to 1, right? So here, what is tan A? From this diagram, the value of tan A is, so this is your angle A because it is given as tan A, right? So to this angle, what is the opposite side? So this is your opposite side, right? What is your adjacent side? This is your adjacent side and obviously this is your hypotenuse, right? So tan A is nothing but, how you can tell tan A? It is opposite side by adjacent side. So here what is the opposite side? BC is your opposite side and AB is your adjacent side, right? So BC by AB. What is the value of tan A? It is equal to 1, which is given in the problem. So in the place of tan A, just substitute 1. So what happens? When you move this AB to the left hand side, 1 into AB is AB. Therefore, BC is equal to AB, right? So here the thing is, we are introducing a new element known as K, okay, just for our convenience. So here the value of AB is equal to BC. Let this term is equal to K, right? K is some positive number, okay, let it be. Now here we are going to use our Pythagoras theorem, right? So here AC square is equal to AB square plus BC square, right? That is the formula. So just write down it, right? AC square is equal to AB square plus BC square. So the value of AC is, here this squaring, when you move to the right hand side, it becomes a square root, right? So what is the value of AB? The value of AB and BC are equal to K. So AB is K and BC is K. So K square plus K square gives 2K square, right? Once you take the square root, what happens? The 2 becomes square root of 2 and K square becomes K, right? So the value of AC is square root of 2K. Now we are going to find the values of sin A and cos A, right? So sin A is nothing but opposite by hypotenuse. So this is your angle A and this is your opposite side, right? So BC by AC. The value of BC is K and AC is root 2 times of K. So K and K cancel each other. Here the answer is 1 by root 2. And the next one is cos A. So here the cos A is given by adjacent side by hypotenuse. So here the value of adjacent side is K. So K divided by hypotenuse is root 2 times of K. So they both cancel and finally we are getting 1 by root 2, right? Now we have to verify, right? 2 sin A cos A is equal to 1. So here 2 sin A cos A. So 2 into what is the value of sin A? It is 1 by root 2. What is the value of cos A? It is 1 by root 2. So root 2 into root 2 becomes 2, right? So this 2 here into, when you multiply these two, we are getting 1 by 2. So again these two 2's cancel each other, right? And here the final answer is 1. So this is the thing which is asked to be verified. So finally 2 sin A cos A is equal to 1 here. Right. Now we are doing with our last example problem, right? Example 5. So here in triangle OPQ, right angled at P. So just draw a triangle and it should be right angled at P. Here the value of OP is 7 centimeter and OQ minus PQ is 1 centimeter. Determine the values of sin Q and cos Q. Right. So here there is a triangle OPQ. Right. And it is right angled at P. Therefore here we have written it as OP and Q. Right. Even it may be OPQ. Okay. There is nothing wrong. So after drawing the diagram, what is the thing which is given? The value of OP is 7 centimeter. So here it is 7. And another condition is OQ minus PQ is equal to 1. Okay. So let it be. So first in this diagram, you see we are applying Pythagoras theorem. Right. So by Pythagoras theorem, OQ square is nothing but, okay, it is written like this. Anyway, OP square plus PQ square. Right. So here what is given in this problem? OQ minus PQ is equal to 1. So here from this equation the value of OQ can be written as, I am moving this minus PQ to the right hand side, therefore this will become plus PQ. Right. So mark this as equation 2 and let this be equation number 1. So in the place of OQ, now I am going to replace it with 1 plus PQ. Right. So when you replace, you see this expression gets modified as, in the place of OQ, we are writing it as 1 plus PQ. Therefore 1 plus PQ the whole square is equal to OP square plus PQ square. Right. Now this is in the format of A plus B whole square. Right. In the place of A I am having 1, in the place of B I am having PQ. So when you expand, you see A square plus B square plus 2AB. Right. So this is A square. So 1 square is 1 and B square is PQ. B is PQ. Therefore PQ square plus 2AB. Therefore 2 into 1 into PQ, which is nothing but 2PQ. Right. Which is equal to OP square plus PQ square. So here the thing is, now I am moving this plus PQ square to the left hand side. What will happen to it? This plus will become minus. Right. So this left hand side elements, they remain as such. Now this plus PQ square when moved to the left hand side, it becomes minus PQ square. So they both cancel each other. Right. And here in the place of OP, the value is given. It is 7. So it is 7 square. Right. So the remaining terms are, you see, 1 plus 2PQ is equal to 49. Therefore, 2PQ is equal to 48. Right. So, from this, the value of PQ is, you see here, 2 is in multiplication. When you move to the right hand side, this occupies the division part. So, 48 by 2 gives you 24 centimeters. Right. That is 2 2s are 4 and 4 2s are 8. Right. Then, you see, OQ minus PQ is equal to 1. This is given. So what is the value of PQ? The value of PQ is 24. So just substitute it here and find the value of OQ. So to find the value of OQ, what we have to do? We have to move this minus 24 to the right hand side. So that becomes plus 24. Right. So this one remains as such. So 1 plus 24 gives you 25. Right. Now we have to find the value of sin theta and cos theta. So this is our diagram and these are all the values. So sin theta is nothing but, here what is the sin theta? That is the angle is at Q. So sin theta is opposite by hypotenuse. What is your opposite side? It is OP. And what is your hypotenuse? It is OQ. Right. So it is 7 by 25. And similarly, what is the value of cos theta? It is adjacent side by hypotenuse. So what is adjacent to this angle Q? It is PQ. So it is nothing but PQ by OQ. Right. So PQ is 24 and OQ is 25. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.